When we're doing troubleshooting, we've got several different protocols and features that can help us out. One is NetFlow. That's the topic of this video. Our next video is going to be talking about EEM, the Embedded Event Manager, and we've also got CCNP, Simple Network Management Protocol, and syslog. But I want you to be aware that we're going to be talking about SNMP and syslog in module number 10. We're going to take a look specifically at how to set those up and how to troubleshoot them when they're not working appropriately. For now, though, we want to talk about NetFlow. And NetFlow is a feature that can inspect traffic flowing through a network device, and we can get a lot of very granular information about that flow. For example, let's say that PCA sends traffic out to an internet-based web server, and that web server then sends return traffic back to PCA. Well, if we were running a NetFlow on that router that you see on screen, we would have gathered information about two different flows. That's a key point. A flow is unidirectional. One flow was from PCA to the internet, and another flow was from the internet back to PCA. And the router, if it were configured for NetFlow, could have captured information and stored that information in a cache, information about those two different flows. And we could look at that information directly on the router with a show command. I'll show you that live here in just a moment. But let's say that we had more than just this router. We have lots of network devices that are running NetFlow. What we could do is configure all of those devices to send their information to a NetFlow collector. And this NetFlow collector can consolidate all of the information coming from all of those different devices and give us a lot of insight about traffic patterns inside of our network. I'll show you a screenshot in a few moments of what a NetFlow collector screen might look like. It's pretty amazing the level of visibility that we can get if we use a NetFlow collector. But before we get into that, let's take a moment and define exactly what is a flow. Well, Cisco says that packets that make up a single flow have to have 7 things in common. All packets in a flow have to have the same source IP address. They have to have the same destination IP address. They also have to have the same source port number and the same destination port number. For example, let's say that I've got a PC and I'm connecting to a web server on the internet via one browser or on one browser tab, and I open up another browser or another browser tab and I connect to that very same site on the internet. Those would actually be different flows. Yes, they have the same source and destination IP addresses. Yes, they have the same destination port number, port 80 if I'm going to an HTTP site, but the source port numbers would be different. Those would be different flows. Something else that packets have to have in common in order to be classified as a flow is that they have to have the same layer 3 protocol type, such as IP. Also, they have to have the same type of service or TOS value. Here we're talking about a quality of service marking. In an IP version 4 packet, as an example, there's a field called the TOS byte. And this TOS byte has 8 bits in a byte, and we might use IP precedence or DSCP, Differentiated Services Code Point, to mark a priority value in that TOS byte. We've got a couple of options, but the TOS value needs to match between packets if those packets are to be considered part of the same flow. And finally, the packets have to be coming into the router on the same interface. They have to have the same ingress interface. And if we are using a NetFlow collector, which is a great idea in a large environment, we might get a screen something like this. And by the way, there are many fantastic NetFlow collectors out on the market. Cisco has the Cisco Network Analysis module. That's an example of a NetFlow collector. The one I'm showing you on screen is a screenshot from Live Action. And this is from a company called Action Packed Networks. And I'm showing you this software just as an example because this is the software that I most often use. But notice how valuable this type of visibility can be when we're doing troubleshooting. We can see exactly what path is taken from one device on the network to another device on the network. We can zoom in, we can get quality of service information. Maybe we're having some delay in our voice packets. We could go in and see how much jitter is being experienced by our voice packets. Are the type of service values marked correctly on the voice packets? And at the time of this recording, you can go to their website at liveaction.com and you can download, I think it's a 14-day free trial if you want to play with this a little bit and see what a NetFlow collector might do for you. But when it comes to troubleshooting, it can be very valuable to be able to see exactly what flows do we have on the network, what paths are those flows taking. Now let's go out to a live interface and see how to set up NetFlow. In this demonstration, we want to set up NetFlow on router R1. Specifically, I want it to be able to monitor flows going between the PC and the internet. And I've got a router acting as the PC. It's not configured with a routing protocol, it's configured with a default gateway. I've got another router acting as the internet. And what we want to do is configure NetFlow on router R1. Let's go into global configuration mode, but we need to enable an interface or interfaces for NetFlow. What I'm going to do first is go into interface fast Ethernet 0/0, and I'll say IP flow ingress. In other words, I'm telling this interface to keep track of flows coming into this interface. I could say IP flow egress. I could give a second command that said that. That would also make this interface keep track of flows exiting this interface. Remember, a flow is a unidirectional thing. If I've got a telnet session set up between a PC and a host on the internet, that's two flows. But in this case, I'm going to be a bit more creative. I'm going to go into interface serial 1/0, just to show you the flexibility of this, and I'm going to say IP flow ingress here as well. You see, this way, as traffic is coming from the internet back into R1, or as traffic is coming from the PC going out to the internet, I'm going to be monitoring those flows. As traffic comes into either of my interfaces, I get to monitor those flows. And now let's create some flows. Let's go to that PC, and we'll start off with a ping. Let's ping the loopback IP address on the internet router, which is 1.1.1.1. And let's see if we can successfully ping the internet router. And I can. Let's try it again. There we go. And now I'm going to telnet. Let's say telnet to 1.1.1.1. And I'll log in and I'll log right back out. And now I'm going to telnet, but instead of using the telnet port of 23, I'm going to use port 80. I'm setting up a web session, in other words. I enable the internet router as a web host. Now we've sent 3 different traffic types to the internet. Let's go to R1 and see if we have been monitoring those flows. To check it out, we can say show IP cache flow. And sure enough, we see information about our telnet flows, our World Wide Web flows, and our ICMP flows. And you might be wondering why I have so many flows. Well, before this video, I was doing some initial setup, and I created some flows, and apparently the router is remembering those flows. And while this is great, it does give us some basic information about these flows. If we want even more information, if we want to have a single repository where we can consolidate NetFlow information from multiple devices, we need to set up a NetFlow collector. And let's say that we've got a NetFlow collector as pictured on screen at an IP address of 192.168.1.50. Let's configure R1 to point to that as a NetFlow collector. Let's first set up the NetFlow exporter service. To do that, we go into global configuration mode and we say IP flow-export. And I'm going to say that I'm sourcing my NetFlow packets that are going to be exported. I'm going to be sourcing them from a specific interface on this router. Normally, I'll use a loopback interface. I'll say loopback 0. Next, we can specify the version of NetFlow we're using, IP flow-export version, and it's going to be either version 1, 5, or 9. And this is where you need to check the documentation of your NetFlow collector to make sure it matches up with what we're configuring here. I'm going to say that we're running version 9, and now I need to point to the IP address of that NetFlow collector. To do that, it's IP flow-export destination, and the destination IP address is 192.168.1.50. However, what about the port number? This is interesting. Technically, there is no standard port for NetFlow. You should check your documentation for what your NetFlow collector uses. However, what I've noticed is it's fairly common to see a port of 9996. And I'll say that this does match up with my NetFlow collector documentation, and we'll enter that. And that's how we can configure a router to point to an external NetFlow collector.